If you're studying engineering, you need to know that the math you come across in uni is obviously very different for each type of engineering. You tend to see more complex numbers and Lagrange domains in electrical engineering, ordinary differential equations in mechanical engineering, and derivatives and integrals in civil engineering. Now, all of these sounds really fancy, but realistically, how much of these concepts you get actually to apply on a daily basis as a full-time engineer? Hi, my name is Julio. I'm a mechanical and aerospace engineer from University of Queensland, and today I'm going to dive into the math courses I took when I was in uni, how they linked to my other subjects in mechanical and aerospace engineering, and how much do they come across today at my current job as a full-time graduate engineer. Okay, so what were my math subjects in uni? Let me just try to give you an overview of the type of math we had to look into at the University of Queensland. So we had calculus and linear algebra, multi-derivative calculus and ODEs, statistics, engineering analysis, and control engineering. So in calculus and linear algebra, we had to study the foundations of calculus, obviously. So that means limits, derivatives, integrals, all that sort of stuff. In multivariate calculus and ODEs, so now here we're not looking at derivatives with respect to x, but also we're looking with respect to y and z. So the working plane sort of changes in dimension, if that makes sense. Also, they introduce ODEs, ordinary differential equations, which describe, for instance, the motion of particles in satellites or the rate of chemical reactions, and that was actually such an interesting course. I really liked this one. I think I did okay in this course, but when it got to the ODE part, it started to get a bit confusing, and I'm pretty sure I messed up really bad in that area there. In stats, we looked at sampling methods, exploratory data analysis, standard probability models, estimation, hypothesis testing, which was really useful, and regression. In engineering analysis, we essentially looked at numerical methods, which means just using tools that help us describe the solution to a particular system through computational methods kind of thing. So it's really a lot of coding there. And finally, the most amazing and well-structured course I have studied in my entire life is control engineering. Essentially means looking into systems, modeling principles for electrical and mechanical systems, the Laplace transform, block diagram modeling, open and closed loops. So by how much my math courses were related to other core subjects. Okay, let's try to sort all my core subjects into essentially two main areas: engineering mechanics and thesis. In engineering mechanics, we looked at statics and dynamics, thermodynamics, fluid mechanics, fracture mechanics, and design and manufacturing. In engineering mechanics, we also had these subjects that were more related to project engineering. So they were teaching us how to deal with project management and just communication skills and that sort of stuff. And we had thesis, which is essentially report writing. And during the first 6 months, you run experiments and then you try to acquire all the data. And in the second half, you will try to organize a presentation and just present the results. Now, of course, every single topic that we looked into, we didn't really apply to every single subject in engineering. And here, I'll try to summarize what courses really came across throughout my whole degree. On the left-hand side of the circle, you have my core subjects, and on the right-hand side, my math subjects. The intersection between the two will be the math courses that were relevant to my core engineering subjects. So clearly, linear algebra was something I used on a daily basis. And calculus is something that you will use a lot, particularly in statics and dynamics. ODEs is something that you come across quite often, but not as much as the previous subjects. So not necessarily you would have to revise ODEs in order for you to advance to a different topic, if that makes sense. Engineering acoustics, for example, is one of those subjects where you actually had to look at ODEs a fair bit, but it was the only subject. And for my thesis, I didn't use math at all, which was amazing. It was purely qualitative observation and not really quantitative observation. How much math do I come across today at work? So recently I started working for a water treatment company that essentially treats water before it gets disposed to urban utilities. And urban utilities is a government entity that discharges contaminated water. The job is more linked to process/chemical engineering, although you come across concepts like pipe flow and fluid mechanics, which you would obviously know the very typical concepts that you have to study in mechanical engineering. You won't really apply Lagrange domains, triple integrals, or Euler equations on a daily basis. The math I studied in uni was maybe a bit too much for the problems you actually get exposed as a graduate. So during the first few years of engineering, I really thought I'm going to get across any of these concepts at all. But I strongly believe that the type of engineers that work with these concepts on a daily basis are people that are extremely good at what they do and they get rewarded really well for it. I'm only an entry-level graduate and the math I get to do is very trivial compared to what a senior engineer would normally have to deal with. So math is definitely really important, but it's something that I will most probably have to relearn so I can gain more responsibility to actually use it. Thank you so much for watching, and if you find this video useful, please give it a like and subscribe so you can help the channel grow. It would really help put my videos out there for people to watch, so I would really appreciate it if you give this video a like. And yeah, subscribe for more content like this, and I will see you next time.